Hi, I'm Paul and this is Random Exception. Today I'm going to chat about a project I've called Browser LLM. It runs LLMs locally in the browser with no server backup, everything in the browser. On screen we have NV-top updating every 3 seconds so you can track the GPU, and also the console so you can see some debug info as we go through this brief demo. Right, let's run a Python script. Let's take off there, be concise, because it seems to happen quite quick at the minute. This is a standard React app running Llama 3.2. There's no backend or remote server involved. To prove that, I will just show you that we have no Wi-Fi connected. And as you can see, the inference just continues. We're using WebGPU API to run the model weights directly on the GPU's compute shaders, and this treats the browser as a local runtime, which means zero network latency and total data privacy by default. This is actually being quite thorough. Very cool. Again, everything's local. I built the UI to be a bit more dense than your typical chat app. It's a 14-pixel layout with a 94% vertical stretch. It's typically tuned to a 1080p screen, so you can actually see a full block of code without scrolling. For state management, I'm using Dexy.js to wrap IndexedDB, and every message and session stored in the browser's local database. If I hit refresh, the engine reloads, but my history and context are exactly where I left them. If we look at the application tab, we can see that we've got all the models loaded in cache and the database, which is stale, stored as you would expect. Let's give it a new chat and let's look at the hardware tab when we've got a query running. Hardware tab gives you visibility about what's happening on the GPU. Since we implemented real-time tracking, you can watch decode speed and teapot to update token by token as it generates. It also shows memory use, which is your context saturation. If you're on a lower end card, you can use these sliders to prune the key value cache or adjust context slicing. Lets you cap exactly how many previous messages are sent back to the model, which is the most reliable way to prevent an out-of-memory crash during long sessions. This is being quite thorough. The model registry covers different hardware constraints. We've got everything from Phi 3.5 at 3 gig video RAM down to a model just at 100 gig, which is useful for quick utility tasks. One technical detail, though, all these models are Q4F32 variants. Many Linux drivers, especially Mesa, still have issues with 16-bit floats, and using 32-bit floats across the board keeps the shader stable and prevents the device lost errors common on many Linux and Vulkan setups. The app also estimates cost savings based on current API rates. It's a small detail, but it highlights the efficiency of local utility. Overall, it's a stable, private way to use LLMs as a local tool. The code's on GitHub. I've also got a small blog article that you can check out, and the links are below. You just need a few Chrome flags to enable WebGPU, and that's Browser LLM. Any thoughts or considerations would be appreciated. Thank you.